Hello everyone. Okay, so in this video we're looking at geometric series. So let's recall the difference between a sequence and a series. So 2, 4, 8, 16, dot dot dot. This is an example of a geometric sequence because it's each term is being multiplied by my common ratio, which is 2. A series, however, is just a sequence, but you're just adding each subsequent term. Love that word, subsequent, right? So you're adding each subsequent term. So this is a sequence and this is a series. Now what we're looking at today is, well, how can I find the sum of a geometric series up until a certain point? If I say, for example, if I kept this going forever, what would it equal to on the 45th term? Right? What is the sum of the first 45 terms? Or better yet, if this kept going on forever and ever and ever, right? Would it converge at one value? So let's have a look here. So a geometric series is formed when terms of a geometric series are added. So the formula is given by Sn equals a times 1 minus or to the power of n all over 1 minus or, where a is the first term, or is the common ratio, and Sn is the sum of the first n terms. So you don't need to derive this formula, however, but you do need to be able to prove it by induction, which I'll do in a later video. So let's have a look here. For each of the following, find T8 and S9. So we're finding the 8th term and the sum of the first 9 terms, right? So we're looking for T8 and S9. I'm just going to do this one here. So Tn is equal to a times or to the power of n minus 1, and Sn is equal to a times 1 minus or to the power of n all over 1 minus or. So let's find a and or. Well, a is going to be minus 2, and or is my common ratio, which would be 6 divided by minus 2. So just pick any two subsequent terms. That's going to be negative 3. So Tn is going to be minus 2 times minus 3 to the power of n minus 1. And Sn is going to be equal to a times 1 minus negative 3n all over 1 minus negative 3, which would be plus 3, which will be equal to 4. So let's sub these in. So I'm looking for T8. That is going to be minus 2 times minus 3 to the power of 8 minus 1, which is minus 3 to the power of 7. 4, 3, 7, 4. So the 8th term of the sequence is 4, 3, 7, 4. And then the sum of the first 9 is going to be, let's say a here is equal to minus 2. So minus 2 times 1 minus negative 3, the power of 8, all over 4. So the sum of the first 9 terms here will be 3, 8, 0. So the sum of the first, sorry, the power of, sorry, looking for S9. I do apologize. S9. The power of 9 here. That's actually going to be minus 9842. So the sum of the first 9 terms is minus 9,842. And then the 8th term is 4,037. So now, what about the case of if I have a geometric series that goes on forever and ever and ever and ever and ever and ever and ever? So this is when we're going to use the sum of an infinite geometric series. So if I have a geometric series that goes on forever and ever, and my common ratio, right? If my common ratio is between minus 1 and 1, i.e. the absolute value of my common ratio is less than 1. So if it's like a fraction, right? I can use this sum to infinity formula, which is just a over 1 minus OR. You must be able to derive this formula, so I'll do that in a separate video. But let's have a look here. Okay. So why does OR need to be less than 1? Sorry, this is just not working with me. Why does OR need to be, why does the absolute value of OR need to be less than 1? Because we want our series to converge, okay? And what does converge mean? It just means it gets, converging means it all kind of heads towards one value, right? So for example, right up here, like a half plus a quarter plus an eighth plus a 16th plus 1 over 32. As we can see here, the values of my terms are heading towards 0. That is because I'm multiplying by a half every time, right? So if I kept this going for an infinite amount of time, right, eventually I'm adding like 0. So if the common ratio is greater than 1, right, my sequence will diverge, right? It will just go to like infinity, right? Because if I had here, say 2 plus 4 plus 6 plus 8 plus 16, and kept going forever and ever, right? Well, my common ratio here is 2. And it's going to diverge. It's just going to go to like infinity because, well, obviously I'm adding all these whole numbers together. Of course, it's going to go to like be infinity big. So, yeah, and then if it's less than 1, right, it has a limiting value and it converges to its limit. So let's find the sum of the infinite geometric series here. So a is equal to 1. My common ratio is going to be a half divided by 1, which is a half. So my sum to infinity will just be 1 over 1 minus OR, which is a half, 1 over a half, which is equal to 2. So 1 plus a half plus a quarter plus an eighth plus a 16, right? Continue on to infinity, right? The sum to infinity will converge to. That's it there. All right. What about if I have summation notation? So I'm looking for the sum of this function here from n is to 0 up into infinity. So let's write out a few terms here. My first term is going to be 1. My next term is going to be 12 over 17. My next one then is going to be 12 over 17 squared plus 12 over 17 cubed, goes on forever and ever. So a is going to equal 1. My common ratio is going to be 12 over 17. So I'm looking for the sum to infinity, which is 1 over 1 minus 12 over 17, which is 1 over 5 over 17, which is going to be equal to 17 over 5. So this sequence, right, will converge to 17 over 5 if I add it on forever and ever. Right. And I'll leave it there for that. I'll do some exam questions in the following video, but that is the sum of an infinite geometric series, and I hope this video was some help to you guys, and I'll catch you guys later. Bye.